Hi, good afternoon, President Ramirez and fellow board members. I appreciate having a little of your time this afternoon to share with all of you essentially the first 7 months of data that is being collected at the wonderful, sorry, I'm just pulling up the slideshow as we speak, air monitors that the board approved a little bit more than a year ago, about a year and a half ago. I will keep it brief. We are talking about air quality, so it gets really technical and down in the weeds at times, but I'm going to attempt to float above all that and give you guys really the kind of meat of the what we're seeing and the sort of science we're looking at. So as the commissioners will remember, we have placed these monitors on the roof at Haycox Elementary, which is down on Perkins. Many of you are familiar with that location there, and is adjacent to Hueneme Road as our corridor there, and then in a large residential area typical of South Oxnard. A little more than a mile to pretty much due east of the port. This location was selected because of its kind of representation of the broader community and then the proximity to the port. We began monitoring back in December of last year, so in a few months, we will be coming up on a full year's worth of data. Now, what does this stuff look like? Well, you will remember when we had the sort of unveiling ceremony, we had some of the equipment out on the table for the community to see. This is what it physically looks like in location on the roof there. We purposefully positioned it in a place where it would be and less visible from the road there. And what we're actually monitoring for is essentially two things. We're measuring for tiny, tiny air particles called particulate matter of different sizes. And then we're also measuring stuff around kind of what the atmosphere is doing. What is the temperature? What is the wind? What is the direction the wind is coming from? So you can see the one on the right that looks sort of like a mini fridge. That is the enclosure that contains the expensive high accuracy monitors. And then the tree looking thing on the left is our sort of atmospheric measurements and the little small mobile monitors. So those two work together to give us our information. So you will remember from that unveiling, this piece of equipment was available for the public to see and sort of look at and ask questions about. This is our reference grade particulate monitor. And the reason that reference grade piece is important is because there's a full range of air monitoring equipment, from the inexpensive, small, mobile types of monitors, all the way up to the other end of the spectrum, which is this monitor. And so this monitor gives us information, data around the air quality that is the same quality as that which a group like the Environmental Protection Agency, the Air Resources Board, the Air District would use the same type of data. So it is the very highest quality data available. So it is really kind of the standard. If one were to ask what is air quality like in Ventura County, a monitor like this would be where they would get their answer. So this piece of machinery here is measuring 3 different sizes of that particulate matter, including humidity. And humidity is really important because, of course, humidity is just a measurement of moisture in the air. But those moisture pieces, those little bits of water, right, are acting like little sponges. So they're grabbing pieces of dust or other particulate out of the atmosphere all the time. So the more water you have, the more difficult it can be to get a really accurate measurement. So that's an important measurement there. The other one that's similarly accurate and of high quality is this one called an Athlometer, kind of a fancy word for saying that this is a machine that does nothing but measure very, very tiny particles called black carbon. And the reason that we're doing that is important because communities, environmental justice, public health advocates, etc., have become very, very focused in on something called diesel particulate matter. And diesel particulate matter is essentially a combination of byproducts that are left over from the combustion of diesel fuels. And not just diesel, it's fuels that are similar to diesel. So gasolines and distillates and bunker fuel and a whole bunch of stuff. They put out a kind of a variety of air pollution that includes gases and particles. And diesel particulate matter in and of itself is very, very difficult to monitor for because of that sort of mix of all the different things in it. So black carbon is the surrogate that is used in place of diesel particulate matter. So we test for black carbon to understand what the diesel particulate matter that's out there would actually look like. And this is widely done, and this is a means of understanding what that DPM, which is the acronym for diesel particulate matter, looks like. And then the other really important piece to this is that black carbon doesn't just come from burning diesel fuel. It also comes from burning other organic substances, wood in particular. So anytime people are having a fire at home in their fireplace, anytime there is a brush fire or a forest fire, this machine can allow us to differentiate between which is which. When is it brush fire smoke and when is it diesel smoke? So that's a really important thing we'll talk about a little bit more. We put up a series of these little small handheld meters. These are less accurate, of course. And what we're trying to do with these is create a relationship between the little ones and the big fancy one so that we can be able to use these little ones in other locations, take them down, put them at the port, put them at a community location, and understand what the readings should actually look like based on that. So why particulate matter? Why black carbon? Well, of course, so particulate matter 10, that's the biggest number. It's the biggest size. It's things like dust, right? If you were to be walking on a dirt field, the dust that would get kicked up, that is PM10. That would get stuck in your nose, stuck in your mouth. PM 2.5, much smaller, 4 times smaller. That stuff goes through your mouth and down into your lungs and can get basically into your lungs. PM1, which is again half as small and more than 2.5, these are tiny, tiny particles. And these can go into the bloodstream and can travel all around the body and can get into different organs and cause different negative health outcomes. So that's why that fine-grained stuff, that really small particle stuff is really getting a tremendous amount of attention from the state in particular. The California Air Resources Board is very focused on PM and DPM right now. So where does this stuff come from? Where does the black carbon that we're measuring, the diesel particulate matter that we're measuring, where is this coming from? Well, it comes from a couple different sources. On-road stuff, so all the trucks, buses, cars, trash trucks, vans, everything out there. Off-road stuff, so our ocean-going vessels, the ships, construction equipment, cargo handling equipment, trains, agricultural equipment, whether it's a tractor or groundwater pump. But then again, of course, we've got that other piece that is that biomass, that is that plants, wood that people are burning and those wildfire pieces. So that's that sort of mix of combination of stuff. Typically, that sort of brush fiery wood stove stuff is less than 20%, but that can change, and we'll see that. So wildfire. Wildfire, as you guys know, is one of the most visible signs of our changing climate and is one of the most readily obvious sort of sources of bad air quality. We all know, and we've all seen and breathed in the last 2 months, smoke from fires that can be hundreds of miles away from us, sort of lending to this, how fluid air is. Air moves all over the globe. That smoke that came from California wildfires is being measured in Europe, parts of Asia now. It circumnavigates the entire world. So why is wood smoke bad? Why do we care about this? Well, because when there are wildfires nearby, those average concentrations can increase by 20 times or more. Those really high peak levels can go up by more than 100 times from wood smoke. So it's very important to us that we understand when there is wood smoke, where is it coming from? Is it wood smoke? Those sorts of questions, because what we're trying to do is help to understand when there's bad air quality in the Oxnard Plain, where is that pollution coming from? So let's cut to the chase. What are we talking about? What are the numbers? Here we have our first 7 months of data, December through August, and this is black carbon again. And the units that we're talking about here are, of course, micrograms. So that is 1,000th of 1 gram. If you were to take that and put it into a big box, a meter cube, if you were to drop 1,000th of a gram into that box of air, that would be a microgram. So what we're seeing is January, December, February, those cold weather months are our worst air quality months. And then our numbers have gotten sequentially better all the way until August. And then in August, because of the fires, those numbers went back up again. And we'll get into some more detail as to why this is, but this generally is showing us that air quality is very good and it's very consistent. And that's really important. That consistency is important because bad health outcomes come from long-term exposure to bad air. So if we have long-term consistent numbers showing good air, we can say that overall air quality in the Oxnard area is very, very good. So this is just another diagram showing you those first 3 months, December, January, February. See how that bar is almost twice as high as all the subsequent months. So that's showing we have bad air when it's cold and better air as it starts to warm up. Why is that?
Giles,
Yes.
could you go back to that slide before?
This one?
If I was going to try to shoot bullet holes in it, I would go, well, in March, we got shut down, with COVID, everybody stayed off the road. So how does that impact this data?
Absolutely. That's a great question, Commissioner Rooney. I appreciate that. I will show you the answer to your question in just a second because we actually have the data showing when there are ships present and when there are not ships present, and showing our numbers of ships from last year as a comparison against this year. So let me just jump into that in just one moment. I just wanted to display kind of the why this stuff is bad in the winter. And the reason it is bad in the winter is really because of atmospheric science. Wonderful complexities of air and temperature, right? When air gets hot, it gets bigger. It's why a hot air balloon rises up. Or when you have a fireplace and all the heat goes up to the ceiling. That cold, dense air sinks to the ground, to the bottom. So in the winter, everywhere, Oxnard, Ojai, etc., we get a very cold layer of air that gets squished by a very thin layer of warm air with heavy cold air sitting on top of it. It's kind of like a cake. And so the same amount of pollution is getting made all the time. That source, the source of pollution, the cars, the buses, they're all just driving, doing their thing. But the amount of air in which all that pollution is sitting gets squished in those cold months by more than half. So you have half as much space for the same amount of pollution, so it gets twice as bad. That's really what's driving that. So we're going to do a quick comparison against LA Long Beach and Hueneme. The purple line you can see here, that's LA Long Beach numbers. The lower darker line, that's our Haycox monitor. So the message here is that we're basically, the air quality is about twice as good consistently across. Same thing here. This is without any fire data included there. So same thing, about twice as good as those LA numbers. So now, Commissioner Rooney, to answer your question, how do we know it's not a COVID-related artifact that we see these decreases? Here is December. We're going to look at ships in port and no ships in port. What we're looking at here is each of these dots is a 1 hour average. Each image, left and right, has 720 dots on it. If you see blue, blue means good air. If you see red, red means bad air. And where the dot is on the map tells you where that wind was blowing to blow that air into the monitor. So as you can see, the bad air that we see in December, when there's ships at the dock, is coming from the north. It's not coming from the west, where the port is located. When there's no ships, you see the same thing. You see bad air coming from the north and from the northeast a little bit as well. But predominantly, even in the bad air times, you see good air, lots and lots and lots of good readings. Same thing in January. Ships, no ships, same thing. Same thing in February, another cold month. Lots of clean dots in the center, These bad dots, if we want to call them that, these are all taking place at 2 and 3 in the morning, when the air is the very coldest, when that layer of air is squished to its very thinnest. If you want to breathe the worst air in the entire year, go outside at 3 in the morning on Christmas morning. Santa Claus gets it because everybody's having a fire and everybody's, got their fireplaces going, and that cold air again squishing. February, we see it. March, same thing. Now, March is interesting because, as you guys know, having been around the port for a long time, in the spring, that air, that wind starts to shift from being gentle to blowing out of the west. So see this little clump of what looks like feathers right in the middle? That's like a wind rose that's showing us wind direction. And the more colorful and the longer, they kind of look like turkey feathers, the longer they are, that means the more wind. So here we start to see, look at that. This is April. We see long turkey feathers from the west. That means air blowing in from the west. Again, lots and lots of good air. A little bit from the west, but those readings, again, were very late at night. That's essentially the story here, is really that air in Oxnard is really, really fluid. It's really about consistent numbers, good quality air numbers that we're seeing there. There's lots more data I could show. We can really sink our teeth into this if you guys are interested, but I wanted to give you kind of that high level. And the takeaways are essentially that we have consistently very good quality air. The worst air that anybody breathes in Oxnard is really being driven by long-term seasonal changes in the temperature and wind regime for the area. That there isn't a distinct signature of port pollution discernible in this monitoring data. And that's important because it says that, as we had hoped, air quality is consistent, it's fluid, and it's good quality.